Okay, this time our video tutorial is about ellipse, one of the type of conic section. Let us define an ellipse. It is a set of all points in a plane. The sum of most distances from two fixed points is constant. The fixed points are called foci. Here is the diagram of an ellipse. This point P moves so that its distance, the distance is Pf plus Pe prime is always constant. This is equal to 2a. Let us identify where is this a. The distance from the origin, here are the other points, the intersection of the graph of an ellipse with the xy plane. From the origin to this point B, it has a distance a, so its coordinate is a0, and also from the origin to point B prime, the distance is also a. From the origin again to this point F has a distance c, so that its coordinate is c0, and this F prime also has distance c from the origin. Another points, this points here, this line, this segment is called minor axis, and this line is the major axis. This length from the origin to this point is b, while this length is a, and this length also is c. Now let us derive the equation of an ellipse. So from its definition, we can have the sum of other distances, which is also equal to 2a. B prime is equal to 2a. Vf plus Fb prime is also equal to 2a. Bf plus Vf prime is also equal to 2a. Let us derive the equation of an ellipse. So from our definition, let us determine the distance Pf from point P to F using a distance formula. So x minus c square plus y minus 0 square plus x minus negative c square, so minus and negative becomes positive, plus y minus 0 square, so we have this left side of the equation all equal to 2a. Now let us simplify the equation by eliminating the square root symbol. Transfer one of the square root term to the right, that becomes this one, and squaring both sides of the equation to eliminate the square root symbol. So the square of this square root is the square is equal to the radicand, and this binomial term squared expanded, and the right side when squared, the middle term still contains a radical or square root symbol. Cancel out what is common to both sides of the equation to simplify the equation, and transfer positive 2cx to the left becomes negative. This term 4a squared transferred to the left becomes negative. So we have only one square root symbol at the right side. Multiplying the whole equation by a common factor, multiply the whole equation by 1 over negative 4a. To simplify what is common, both sides are multiplied. So the result is cx over a plus a, and we have left with one radical symbol at the left side, at the right side. Squaring both sides again to eliminate the square root sign. So there's no more square root symbol. Cancelling what is common to both sides of the equation, 2cx is common. Then we have a squared, this c squared transferred, this term involving x squared together with the x squared, and x squared is removed outside, plus y squared. Rename these fractions. so that we can assign b square equal to a square minus c square. Then this is simplified further. This the left side becomes b square, and this is b square. Then again, this equation multiplied by 1 over b square, so that we come up with the simplest form of an equation. The left side is equal to 1, or we can interchange both left and right side of the equation. This is an equation of an ellipse whose center is at the origin. Okay, this is the first type of an equation of an ellipse where a is greater than c and c is greater than 0. B is equal to square root of a square minus c square. So we have here an equation of an ellipse with center at the origin. This is type 1 of an equation of an ellipse. This is the orientation of the ellipse. And with its corresponding equation, x square over a square plus y square over b square equals 1. So this line is the major axis, and this vertical line is the minor axis. And with its corresponding points, b, b prime, f, a prime, and this covertices. Okay. Next, if the foci is at these points, 0c, 0, negative c, with its corresponding graph, the ellipse this time is positioned vertically. Its corresponding equation is y squared over a square. Take note that in type 1, above a square is x, here it is y. Okay, so this is c. Now, for example, we will use the equations of the ellipse that we have derived to sketch the ellipse. Sketch the following ellipse showing its vertices and its foci. The equation of the ellipse is x squared over 25 plus y squared over 16 equals 1. So this is type 1 of an equation of an ellipse. Now let us identify what is A, B, and C, so that we can plot the corresponding points in an ellipse. So A is 5, square root of 25. B is square root of 16, 4. So C is equal to square root of A square minus B square. So A is 5 and B is 4. Simplifying, extracting the roots, C is 3. So we can plot now, or we can sketch the graph of an ellipse. So C is 3. So this is our point, 3, 0. And this one is negative 3, 0. A is 5. So our B vertex is 5, 0. And negative 5, 0. B is 4. So this is 0, 4 and 0, negative 4. Okay, this is the sketch of the ellipse. Next, sketch the ellipse showing its vertices and foci. Okay, this time the equation is y squared over 25 plus x squared over 9 equals 1. This is the second type of an ellipse. So again, let us identify A, B, and C. A is square root of 25, which is 5. B is square root of 9, which is 3. So C is square root of A square minus B square. Substitute and simplify. C is 4. Okay, so that our focus is 0, C. C is 4. So with A, B, and C, we can plot the exact location of the points on the graph of an ellipse. So this is the equation, graph of an ellipse. Sketch of the graph. So this is the foci is 0, 4, vertex is 0, 5, corresponding to our points. Okay, next example. Find the standard equation of the ellipse whose foci are 3, 0 and negative 3, 0 such that any point on it, the sum of its distances from the foci is 10. So first, let us plot these points. F and F prime. Okay. So this belongs to type 1. So F, the 2 points are here, F and F prime. So that from this graph, this length is C. So we can have C equals, A is being solved first. According to the problem, from any point, the sum of its distances, meaning the PF and PF prime, the sum is 10. That sum is always equal to 2A. So 2A equals 10 according to the problem. Solving for A equals 5. And of course, C is 3. From the origin to this point, that is C, equal to 3. Next, we are left with to solve for B. B squared equals A squared minus C squared. Substituting and simplifying, extracting the roots. B is 4. So, the equation of an ellipse, we are asked to find the standard equation. This equation, we will substitute for A and B. So, our equation is x squared over A is 5, is squared 25, B is 4, is squared 16 equals 1. Okay. Next, find an equation of the ellipse whose center is at the origin and with foci at positive negative 5, 0 and vertices at positive negative 7, 0. Let us sketch first the ellipse. Okay. So this belongs to type 1 again, with the corresponding points, vertices B and B prime, foci F and F, this is F prime. Its standard equation. Okay, so from the origin to this point, this is A. This length is A, so A is 7. And from the origin to this point, this distance is C, so C is 5. Then we will solve for B. Substitute A and C and extract the square root. So B is equal to 2 square root of 6. 24 is 4 times 6. Square root of 4 is 2. 2 times square root of 6. So the corresponding equation is x squared over A. A is 5, so 5 squared. Or rather, A is 7. 7 squared is 49. B is 2 square root of 6 squared, it is equal to 24. Okay. Now, if an ellipse is no longer centered at the origin, so the equation of an ellipse in standard form, where A is greater than C and C is greater than 0, and B is equal to square root of A squared minus C squared. If the center of the ellipse is no longer at the origin but in some point C its key, so the foci this time is F of H plus C key, and the other foci, this is F prime supposedly, and vertices. So here is the equation of the ellipse with center at its key. And B, of course, is B squared is equal to A squared minus C squared. Its corresponding graph is this one, the center of the ellipse at its key. So moving to the right, since this distance is C, so the coordinate of the focus is H plus this distance C. Okay. The same y coordinate key. And the coordinate of this one is H plus A, because this distance is A. So H plus A. And the same y coordinate key. On the other side, H minus A, moving to the left. And moving up, since this is B, so H, comma, key plus B, since this is B. and down minus b. Okay. So the major axis is horizontal. Okay. Next, with the same condition, and the ellipse is centered at its key, and the position of ellipse is vertical this time. The major axis is this vertical line, x equals h. Its corresponding equation is y minus k square over a square plus x minus h square over b square equals 1. Okay. B again is the same. B square equals a square minus c square. Or supposing c is unknown, a and b are given, this is the equation. So this is the major axis. Okay, example 5. Sketch the ellipse showing the center, foci, vertices, and the endpoints of the minor axis. This equation. First is to transform this equation into standard form of an ellipse. Okay, dividing its term by 900 so that the right side becomes 1. Then reduce to lowest term, 900 divided by 25, 900 divided by 9. So the resulting equation is this one. The y term, its denominator is 100. So this is type 4 of our equation. So we can rearrange this one, the term. This term is the first one. So that this is A and B. So we can identify. Okay. The first step to plot the graph of the ellipse is to lay out the major axis. So this is our xy plane. And this line is the major axis. The major axis is taken from equating the term involving the b square. The fraction involving the b square. The numerator is x minus 2. So equate x minus 2 equal to 0. So x equals 2. So this equation, this line is the graph of the equation x minus 2. So that is our first step in sketching the graph of an ellipse. After we transform this given into standard form so that we can identify A and B and solve for C. So the major axis is equating the numerator of involving B. X minus 2 equals 0 and x equals 2. So this is the graph of x minus 2. Then this is type 4 of our equation of an ellipse. Okay. Identify A. A is 10, B is 6, C is a square minus square root of a square minus b square. Substitute A and B, then simplify and solve for C. Extract the square root of 64, 8. C is 8. Okay. So, let us identify the points, focus, vertices, and covertices. Center is its key. So, this is h is 2, key is negative 4. Okay, so our center is 2, negative 4. The focus, h, comma, k plus c. H is 2, k is negative 4, plus c is 8. Negative 4 plus 8, simplified. This is 2, comma, 4. F prime, h, comma, k minus c. Okay, h is 2, k is negative 4, minus c, c is 8. So, negative 4, negative 8 is negative 12. Next, the vertices, h is again is 2, K is negative 4, A is 10, so negative 4 plus 10 is 6. The other vertex, K minus A, so negative 4 minus 10, negative 4 minus 10 is negative 14. Then the endpoints of the minor axis, it's 2 plus B, 6, K is negative 4, so it is 8 negative 4. And the other covertex, it's minus B, so 2 minus 6, and K negative 4, so it is negative 4, negative 4. Let us plot the points. Okay, so we have here the plotted points and the corresponding graph. Here is the corresponding graph of the ellipse. So this is now our sketch of the ellipse. Okay, next example. Give the coordinates of the center, foci, vertices, and covertices of the ellipse with the given equation. Sketch the graph and include these points. Our equation is this one. Let us transform this equation into standard form. So, grouping the term involving x, y. So, 9x squared minus 156x plus 16y plus 64y. Then, remove what is common to x squared and x, and also with y squared and y. The common here is 9. Common here is 16. Then inside the parentheses, complete the square. So this becomes perfect square binomial would be the result. So to complete the square, we have to add the square of 1/2 of the coefficient of b in standard equation of a quadratic equation. So 14 divided by 2, okay, 1/2 of 14. 7 square is 49. This one, 1/2 of 4 is 2. 2 square is 4. So we add to the right side 9 times 49 plus 16 times 4. Okay, simplify first. This becomes perfect square binomial. This one also y plus 2 square. Then combine, simplify. And then this divide the whole equation by 576. So that this becomes 1. And reduce 576 divided by 16 and so with 576 divided by 9. So the resulting equation is x minus 7 square over 64 plus y plus 2 square over 36 equals 1. So this is now our standard equation of an ellipse. This is type 3 in our standard equation, type 3. So let us identify A, B. So A is square root of 64, 8. B is square root of 36, 6. Then C is solving the equation, substituting A and B. Then extracting the square root. C is equal to square root of 28 or equal to C is equal to 2 times square root of 7 or approximately 5.3. Then our center is its key, so 7, negative 2. Here is our center. This is our center. Then identify, rather plot the points. This is the center. Its key with coordinate 7, negative 2. So let us plot the points as rather plot the actual points. Okay. Focus is F or host coordinates is H plus C, comma K. So H, C, and K. We have here H 7, C 5.3, K is negative 2. So our first focus is 12.3 and negative 2. The second one is this, instead of plus, minus. So that is 1.7, negative 2. Our vertex H 7, A is 8, K is negative 2. So 7 plus 8, 15, comma, negative 2. And the other vertex, instead of plus, minus. So this is negative 1, negative 2. And the covertices, H, this one, H, comma, K plus B. Our H is 7, K is negative 2, plus B, which is 6. Simplify, it is 7, 4. The other covertex, this becomes minus. So negative 2 and negative 6. 7, negative 8. So plot the points on the coordinate axis. First step again, the major axis is the graph of the line y plus 2. Equate y plus 2 equal to 0 because this is the numerator of the term involving b. So y plus 2 equals 0, then it is y equals negative 2. So this is now the line y equals negative 2. And the center, 7, negative 2, this one. And the other points, these points f, f prime, b, b prime is plotted also. Its coordinates. And the graph is this one. So this is now the sketch of the graph of the given equation. Our next sample. The problem is the foci of an ellipse are negative 3, negative 6, and negative 3, 2. For any point on the ellipse, the sum of its distances from the foci is 14. Find the standard equation of the ellipse. Okay, let us plot first the points, the foci on the coordinate system. Its coordinate. Okay. From these 2 points, the foci, the center of the ellipse is the midpoint of these 2 points. So let us determine the midpoints of these 2 points as the center of the ellipse. Okay, this the midpoint. We are going to add negative 3 and negative 3 divided by 2. 2 plus negative 6 divided by 2. So the midpoint, which is the center of the ellipse, negative 6 divided by 2, this is negative 4 divided by 2. So the center of the ellipse is negative 3, negative 2. Okay, so next, the distance from the center to the focus is C. So let us determine this distance. 2 minus negative 2, or we will just count the number of units from negative 2 to positive 2. So 1, 2, 3, 4. So C is 4. So what else we have? We need to determine. Okay, according to the problem, the sum of its distances from the foci is 14. Well, for any point on the ellipse, the sum of its distances from the foci is 14. So, from any point, we know that the sum of the distances from any point to the 2 points, the foci, is equal to 2a. This distance is equal to 14. So 2a equals 14. So solving for a is equal to 7. So we have now A is equal to 7 and C equal to 4. So we need to determine B. So this position of the points indicates that the type of the equation of the ellipse is type number 4. Okay, so we need to find B. B square is equal to A square minus C square. Substitute A and C. A is 7, C is 4. So solving for B, B is equal to square root of 33. Okay, so we will use this equation, standard equation of the ellipse for this orientation of the ellipse, where the major axis is vertical. Substitute K is equal to -2, A is 7, H is -3, B is square root of 33. Simplifying the equation, our standard equation for the ellipse is quantity y plus 2 squared over 49 plus x plus 3 squared over 33 equals 1. So this is the graph of the ellipse. But the problem is asking only for the standard equation of the ellipse. So this is our answer. Next problem. An ellipse has vertices 2 minus square root of 61 comma -5 and the other vertex is 2 plus square root of 61 minus 5 and its minor axis is 12 units long. Find the standard equation and its foci. Okay, let us plot first the points, the vertices. Here we have our coordinate system. Let us simplify first and eliminate radical or radical symbol so that we can determine the exact location of the point. 2 minus square root of 61, square root of 61 is 7.8. So 2 minus 7.8 is -5.8 comma -5. That is one vertex. The other vertex, square root of 61 is 7.8 plus 2, that is 9.8 comma -5. So these are the two vertices. Let us plot these vertices on the coordinate system. And the midpoint of these vertices is the center of the ellipse. Okay? So since the vertices lie on a horizontal line, so this is type number 3 of our standard equation of the ellipse. So let us determine the midpoint of these vertices. So we add -5.8 plus 9.8 divided by 2, -5 plus -5 divided by 2 to determine the center or the midpoint as the center of the ellipse. So simplify. This, the sum is excuse me, 4 divided by 2. This is -10/2. So the center of the ellipse is 2, -5. So let us plot that point. Okay. Next, from the center to the vertex, that is the length A. From the center to either of the vertex, that is A as the length. So A is equal to, this is 2, 9.8 is the same as 2 plus square root of 61 minus 2 as the length of A. Simplify. So A is equal to square root of 61 or in decimal 7.8. Next, we're going to determine, according to the problem, its minor axis is 12 units long. Okay. The length of the minor axis is 2b. The total length of the minor axis is 2b. Accordingly, it is 12 units long. So let us solve for b. B is equal to 6. So we have now A, B, and we need to find C. Okay? This Orientation of the points indicates that the type of the standard equation of the ellipse is type 3. We will substitute its key A and B. So its is 2, key is -5, A is square root of 61, B is 6. Okay, so x minus 2, k is -5, a is square root of 61, and b is 6. Simplify further. So this is our standard equation of the ellipse. Okay, let us determine c. C square is equal to a square minus b square. So substitute a and b. Then simplify, c is equal to 5. So we can determine now the focus. The focus is 2 plus c, or 2 plus 5, comma, -5. Simplify, this is 7, -5. And the other focus is c minus, or rather, this is h minus c. So 2 minus 5. Simplify, that is -3, -5. So our focus are these points. Okay? So the problem is asking for the standard equation and its focus or foci. So this is our answer, and these 2 points. So this is the graph, the actual graph of the ellipse. Okay, that's enough.